Today we'll show you how we engineered ZeroLayer, our autonomous microservice factory. This system will fundamentally transform enterprise software delivery. ZeroLayer takes business requirements and acceptance criteria as input and autonomously produces fully tested production-ready microservices that integrate directly into your deployment pipeline. The result is a dramatic reduction in development time, enabling enterprises to deliver critical business capabilities faster, more reliably, and at scale. My name is Eric, and I'm part of GoodLabs polyagentic AI engineering team. Today, we'll walk you through why we built ZeroLayer, how it works, and how its autonomous microservice factory helps enterprises to move towards an agentic native architecture. We've all lived through this challenge. A business need is identified, requirements are gathered, they're translated into technical specifications, handed to engineering, developed, tested, deployed, and tested again before users finally see any value. By the time the capability reaches production, weeks or even months have passed. That lengthy development cycle doesn't just increase engineering costs, it delays business outcomes, limits an organization's ability to respond to changing market demands, and ultimately degrades the user experience. That's why at GoodLabs, we believe that in the very near future, the traditional application tier will be replaced by a polyagentic layer that reasons directly over enterprise data planes to deliver dynamic functionality to users. As recurring high-value capabilities emerge, it will autonomously generate well-tested, production-ready microservices for maximum performance and efficiency. Today, we'll show you how ZeroLayer's polyagentic architecture autonomously transforms business requirements and acceptance criteria into fully tested, deployable microservices for real-time stream processing on the Confluent Kafka data plane using Kafka streams. The same polyagentic architecture extends seamlessly to Flink, Databricks Spark, and other enterprise data plane technologies. ZeroLayer is powered by a fleet of 7 expert agents, orchestrated with human-in-the-loop oversight to achieve autonomous microservice generation. The workflow starts with the business requirements validation agent, which ensures the provided requirements are well-defined. The app design agent then transforms these requirements into a detailed technical design. This is followed by the test case agent, which generates and proposes a comprehensive test suite which validates the acceptance criteria before a single line of code is written. Once approved, the app code agent builds the microservice, while the debug agent monitors the progress and resolves issues as they occur. The test code agent then generates the unit test code, and the test execution agent executes them against the built microservice. If any test failures are encountered, the debug agent will orchestrate the app code and test code agents through continuous refinement passes until the test cases are satisfied. Once the workflow concludes, we are left with a fully tested, production-ready microservice ready for deployment.
Hey, my name's Alex, and I'm also a part of GoodLabs polyagentic AI engineering team. I'll now walk you through ZeroLayer's architecture, the role each agent plays, and how they collaborate to execute the full agentic software development lifecycle with humans within the loop. Now, let's see ZeroLayer in action. We'll start by creating a new project. For this demo, we'll build a real-time e-commerce application using Confluent's Kafka streams. First, we'll select the foundation model. For this demo, we'll use Anthropic's Sonnet 4.5. It's a highly cost-effective model that demonstrates the power of ZeroLayer's polyagentic architecture, proving that exceptional autonomous software engineering doesn't require the most expensive frontier models. Next, we'll select the input and output Kafka topics so ZeroLayer understands the data schemas it will be working with. In this demo, we'll analyze customer profiles, purchase events, and web browsing activity to derive each customer's real-time daily behavior. These insights enable the e-commerce business to continuously optimize the website experience, deliver more personalized interactions, and ultimately drive more sales. Now that we've identified the input and output topics, the next step is to provide a detailed business requirement. This gives ZeroLayer a clear understanding of the purpose of the microservice enabling it to design and generate code that accurately satisfies the business requirements. We'll do the same for the acceptance criteria. This enables ZeroLayer to generate comprehensive test coverage. And now we're ready to kick off the autonomous code generation. ZeroLayer's orchestrator first invokes the business requirement validation agent to validate the business requirements provided by the software engineering team. This ensures that they are complete, consistent, and ready for autonomous development. The orchestrator brings the software engineering team into the loop to review and refine the business requirements. For this demo, we'll skip that step and we will see how well ZeroLayer performs with minimal requirements. Next, the orchestrator invokes the application design agent to analyze the business requirements and generate the blueprint for the microservice, providing the foundation for the autonomous code generation. Here, ZeroLayer's application design agent breaks down the business requirements into a 14-step implementation blueprint. It starts by ingesting customer profile data to build a lookup table, enriches it with web clickstream activity, processes purchase transactions, applies daily windowing to derive customer behavior, and finally publishes the daily consumer behavior to the output topic. Once the development team confirms the design, the orchestrator coordinates with the test case agent to generate comprehensive test coverage based on the acceptance criteria. This ensures that every business requirement is validated before code generation begins. Here, the test case agent generated 10 comprehensive test cases covering happy paths, failure scenarios, and edge cases, allowing the development team to confirm that ZeroLayer has correctly understood the acceptance criteria before beginning code generation. These include scenarios such as purchases without web activity spanning multiple days to validate daily windowing, multiple purchases within the same day to verify correct aggregation, and other boundary conditions. Once the development team confirms the test cases, we're ready to kick off the autonomous development. The orchestrator coordinates the agent team in a continuous feedback loop of code generation, debugging, and testing, iterating until every test passes and the microservice is production ready. The app code agent first generates the initial implementation. The orchestrator then invokes the compiler and passes the compilation results to the debug agent, which resolves any compilation issues while ensuring the implementation remains faithful to the original business requirements. For very complex microservices, this process typically takes a few iterations to converge. In this case, ZeroLayer struggled with the initial implementation. Rather than patching the code repeatedly, it recognized the underlying issues, learned from the previous attempts, and regenerated a cleaner implementation that better satisfied the business requirements. And it looks like the learning paid off. The regenerated code compiled successfully, and ZeroLayer was able to generate the complete stream processing topology. We can now visualize the complete stream processing topology, showing how data flows from the input topics through each processing stage and ultimately to the output topic. And here we can see the complete first cut implementation of the microservice, fully generated by ZeroLayer. With the application code generated, the orchestrator now coordinates the test code agent and the debug agent in the same type feedback loop. It will generate the unit tests, compile them, resolve any issues, and iterate until the entire test suite built successfully. As you can see, ZeroLayer's test code agent worked closely with the debug agent through multiple iterations to successfully generate a fully compilable suite of unit tests. Now we reach the most challenging stage of the development cycle, test execution. The complexity lies in determining the root cause of every failed test. Is it the application code that's incorrect, or is it the unit test itself that's incorrect? This is where ZeroLayer spends most of its effort. The orchestrator analyzes each failed test, determines whether the issue lies in the app code or the test code, and coordinates the appropriate agents to correct the right component. This iterative process continues until every test passes and the implementation faithfully reflects the development team's intent. And there you have it. ZeroLayer's polyagentic microservice factory has successfully generated a fully tested microservice, packaged it into a deployable artifact, and now it's ready to flow through the CI/CD pipeline for your production deployment. Thank you for joining us for the ZeroLayer Autonomous Microservice Factory demo. If you're ready to dramatically accelerate your software engineering team's microservice development, we'd love to show you how ZeroLayer can transform your software delivery. Contact us today to get started.